we are also supposed to compute LUB, least upper bound of everything. So can you check out? So this is the example that you'll be trying to figure out. And just to have a more revision, I would suggest you find both greatest lower bound as well as least upper bound, even though it is asked specially for GLB or LUB. You'll be computing both. Okay. So I would expect the replies quickly so that we can go ahead. If I am asking about what is the greatest lower bound of pair 2, 3. Okay. So this 2 and 3. What are the lower bounds of 2, 3? The elements which are directly connected with 2, 3. I am observing that 1 is directly connected with 2, 3, and there is no other element apart from 1 which is present. So obviously 1 will be the greatest lower bound of 2, 3. Ready? Fine. Aditya, can you tell me what will be the least upper bound of pair 2, 3? I already said, even though they have asked about particular, we will be computing both. So greatest lower bound is 1. What is the least upper bound?
5.
5. 5, correct. Okay, how come 5? What are the upper bounds of 3, 2? I am having all these. 5, then 9. Okay, I will not say 6 because there is no connection between 2 and 6. So 5 will be there, 9 will be there, then you will have 10. So these are the upper bounds of pair 2, 3. 5, 9, 10. Out of that, 5 is the least upper bound. Okay, fine. First example is clear. Greatest lower bound is 1 and least upper bound is 5. How about second? From girls, I want the reply. What is the greatest lower bound of pair 2, 7? 2, 7. There should be direct connection. Okay, element should be directly connected somehow. So 2, 7. If you have been given a pair 2, 7, can you tell me what is the least upper bound? Sorry, greatest lower bound first of 2, 7. Somebody has given the answer. Okay, for second, Prathamesh is saying greatest lower bound is 1 and least upper bound is 10. Yeah, perfect. Fine. That means you're getting whatever is ongoing. Okay, now check out what are the lower bounds of 2, 7. Lower bounds of 7 are 6, 3, 1. Okay, likewise. I'm not saying 5. Lower bounds of 7 are 6, 3, 1, while lower bounds of 2 are 1. Which one is common in both? 1 is common, so we will say 1 is the greatest lower bound of 2, 7. If we talk about upper bounds of 2, 7, we are observing that for 7, upper bound is only 1, 10, while upper bounds of 2 are 5, 9, and 10. 10 is common, so 10 will be the least upper bound of pair 2, 7. Moving further, what is the answer for third? Greatest lower bound of 5, 8? 5, 8. Okay. It is asked about lower bound. So I will check out what are the lower bounds of 5. 5 is having lower bounds 3, 2, 4, 1. And 8 is having lower bound 6, 3, 1. Okay, 6, 3, 1. So what will be the greatest lower bound of 5, 8? Any answer in the chat box? Yeah, 3, 10. Correct. Very nice. That means you are understanding what is ongoing. Okay, 3, 10. Correct. Mahesh? Yes. Greatest lower bound is 3. Very nice. Okay, and what is least upper bound of 5, 8? Least upper bound of 5, 8? See, I am taking the example which was asked in 2006. Okay. Almost 14 years back. 2008, okay, almost 12 years back. So you are saying least upper bound is? Okay, check out upper bounds of 8, only 10, upper bounds of 5, 9 and 10. Which one is common? 10. So 10 will be the least upper bound of 5, 8. Okay. think you are now clear. What is the least upper bound of 3 comma 2? Least upper bound. Okay. So I hope we have already covered this in the example number 1. Greatest lower bound of 2 comma 3 was 1 and least upper bound was 5. So this will be the 5 answer. Okay, least upper bound. Least upper bound of pair 4 comma 8, 4, 8. So upper bounds of 4 are 5, 9, 10, while upper bound of 8 is only 10. So I'm going to have my answer as 10 here. Okay. And how about this least upper bound of pair 3 comma 5? 3 comma 5, isn't it? T5. So 3, 6, 7, 10, 6, 8, 10, and 5 is related with 9 and 10. So can you tell me the answer for 6? Answer for 6? Answer for 6? I repeat, what is the answer for 6? So I would like to tell you, your answer either 9 or 10 is wrong. That is not the least upper bound of 3 comma 5. Think over it. I will again present the diagram in front of you. The answer is neither 9 nor 10. Whatever examples we have taken so far, all these pairs were not comparable with each other, but for this example number 6, 3 and 5 are comparable. You can observe the upper bounds of 3 are 5, 9, 10. Upper bounds of 5 are 5 itself, 9 and 10. So which one is least? 5 will be the answer. Okay, not 9. 3 comma 5, your answer will be 5. 5 is the least upper bound. Remember the yesterday's examples. Okay. You would question me, why sir we have not taken for this 3 comma 2? Whether 3 and 2 are related by any means? No. If that was the case, if there is a line in between 3 and 2, we would have considered 3 to be a least upper bound of 3 comma 2. But that is not the case. 4, 8, check out whether 4 and 8 are having any relationship. No any relationship. But if you observe a pair 3 comma 5, these are having a direct connection, and 5 is residing at the top of 3. So least upper bound of 3 comma 5 will be 5 and not 9 and 10. Am I clear why it is 5? Am I clear? Still, if you are having confusion, you can simply unmute and you can ask me your doubt. But that confusion should be resolved in the lecture only. Any doubts? No. Okay. Let us know if you are not having any doubt. Not many things to cover. Okay. Same type of example may appear for your examination. So last part from the relations, the concept of lattice. So what a lattice is? Lattice is a partially ordered set or a coset in which every pair of elements has both LUB as well as GLB. So we will be presented with a set and a partial ordering relation. First of all, we will be drawing a hash diagram, and if you are able to obtain least upper bound as well as greatest lower bound for every pair of elements present in that particular hash diagram, you would say that that hash diagram is representing a lattice. The corresponding coset for hash diagram is representing a lattice. So in the terminology of lattice, we are having two new operators. One is join and other one is meet. So in general, if you are having any two elements A comma B, their least upper bound is denoted using join. So hence onwards, in the context of lattice, you can say join. It is represented using this OR operator. Okay. So you are going to have this. If I put hence onwards A or B, this is nothing other than A join B. What is the meaning of it? It is the least upper bound of A and B. whatever it may be. And for denoting greatest lower bound, we are using this symbol, MIT, conjunction symbol. Right? Let me have an example so that your things will get clear. Let us have one poset. Let me try to draw over here. I hope these things are visible properly and there is no any confusion as such. Okay, let us try to draw. Let me have here phi. Okay, let me have here A. Let me have over here A comma B. You can have anything. Okay, I am just taking simple example. And let us have here C. Okay. Let me have arrows. This is the hash diagram for which poset? Poset will be power set of A, where A is having two elements, A comma B. This is so this is the hash diagram for the poset, power set of A comma being a subset of. Now let us check out for every pair whether there exists a least upper bound as well as greatest lower bound. We will go one by one. Okay. So first of all, check out the pair phi comma A. What is the least upper bound of pair phi comma A? Least upper bound will be A itself, and greatest lower bound of pair A comma phi will be phi itself. In the similar manner, if I am considering a pair phi comma A comma B, what is the least upper bound of pair phi comma A comma B? A comma B itself, and its greatest lower bound is phi itself. Right? So for any pair in this hash diagram, we are able to compute both LUB as well as GLB. There is no any pair for which either least upper bound or greatest lower bound doesn't exist. Hence, this particular hash diagram is representing a lattice. Are you getting? This one is lattice. Am I clear? Are you clear with the definition of lattice? Is it fine? Should we proceed with the example? Whether lattice part is clear? Just a second, hold on. I will take one more example. No problem. Just observe these two diagrams. Now, can you tell me which one is lattice and which one is not lattice? Out of these two, let us say this is diagram number 1, which is representing a poset. Both will be posets, but which one is a lattice? That is dependent on the condition. Condition is for every pair there should be LUB as well as GLB existing. If you understood what I am telling, you will be easily able to tell me which one is and which one is not. So Aditya is saying first one is a lattice and second one is not. Perfect, correct. Okay. If you are taking any pairs in the first diagram, you would observe that both LUB as well as GLB exist. You can cross check for any pair, okay? Because we are observing that minimum element is present as well as maximum element is present. But for second diagram, if I am taking a pair I comma j, only lower bound will exist, but there is no upper bound. Okay. So there is no concept of least upper bound for the pair I comma j. In this similar manner, if you are taking a pair, for example, if you are taking, okay, what to say, if I am observing a pair ij, I am not getting upper bound in this case, so definitely this is not a lattice. Yeah, only one, B is not. Yes, correct. In examination, if the question is asked, you will first writing the definition of lattice. What a lattice is? Lattice is a poset in which every pair of elements has both LUB as well as GL, that is join and meet exists. Right? So we are having several properties related with this. Let me clear those properties first. Let L comma less than equal to be a lattice for any pair A comma B belonging to L. First one is LUB of A comma B is given by A or B. You will be reading like this. Okay. A. How to read it? This one is A join B. Second, if I am interested in greatest lower bound of A comma B, I will represent it like A meet. Remember these operators. Okay, concept is same, but the operators, the symbol is different. Nothing. So properties of these meets and joins. Okay, what are the properties? Every element, if I take join of element with itself, it will be. These properties will hold true only if it is a lattice. These properties will not hold true for the general poset. We are discussing in terms of lattice. Every element is least upper bound as well as greatest lower bound of itself. That is the meaning of it. Okay. Next, if you take A join B, what will be result? A join B meet A, we will have A. This is law of absorption. No? If I take A meet A join B, this will also give you A using law of absorption. You can cross check with the help of any sample example. You can check. You have to take out the elements accordingly, and this holds true for associativity as well. A join B join C is equivalent with A join B join C. Change of traces doesn't affect final result. Okay. A These are the several properties which you should remember. Okay. Should we proceed? Just have a note of these properties somewhere. Sometimes there may be a question in the theory exam, final theory exam. Explain lattice along with properties of the same. So you will be explaining along with these properties. Out of these, the property number 3 and 4 are representing law of absorption. This B is absorbed by A. You can observe. Should we proceed? Yes. Yes. Fine. So the very first example for you, okay, front of you, show that the set of all divisors of 70 forms a lattice. This is the question. So yesterday only I told you, if there is such question, that means we need to first of all write a set wherein we will be having all the elements which are dividing that particular number. So herein you have been given set of all divisors of 70. So check out how I am representing this example. So this is the D70. In general, we have seen the DN. DN is set of all divisors of input number n. D70 set of all divisors of 70. 1, 2, 5, 7, 10, 14, 35, 70. These are dividing 70. Then you need to draw a hash diagram for poset. What is the poset? Poset is D70, comma. What is the relation? I already told you. Relation will be divides by. So we will be having a pair A upon B in our relation for perfect division. So how many pairs we will have? 1 1 1 2 1 1 1 2, then 1 comma 10 1 comma 70 likewise. Okay, this one is 10. Finally, I'll be having this hash diagram with you. This is not given, okay. This is my solution that I have written. This is the question. Show that set of all divisors of 70 forms a lattice. That's it. So how you are going to provide a solution? First of all, you will form this set. Then you will write a relation. Relation D70 comma divides by. So you will have elements like all reflexive pairs because every element is dividing itself. So I will have 1 1 2 2 5 5 and so on. Thereafter you have to check out this. Okay. No, you have to check out like this. B upon A, so that you will not have any confusion. B upon B will be in the denominator and A will be in the B in numerator and A in denominator. So you can have pairs like 1 is dividing 70. So I will have this pair. I would say another pair. For example, 14 comma 70. Yes, there is perfect division possible, and you can perhaps have all the other pairs. Later on, based on these pairs, I am drawing a hash diagram. So all self loops, all directions, all transitivity arrows will be removed, and we are presented with this the final hash diagram. Now what to do? Once the hash diagram is ready, you need to check out whether this is lattice or not. How to check? I already told you. You need to check out whether LUB and GLB exist for each and every pair. Are you getting my question? All pairs must be visited. Okay? We will not check for self pair because we know, because of the property of join and mate, every element itself has least upper bound as well as greatest lower bound. How many pairs you will have? 1 2 110 170 17 135, then for 2, then for 5, then for 7, again for 14 35, and finally 70. So you need to check. So any confusions whether LUB and GLB exist for every pair? Whether it exists for every pair? Yes or no? Whether this will be a lattice or whether this is not a lattice? Yes, it is lattice. Okay. But how to show? If this question is asked for 8 marks, how to show? There should be some proper way. So for proper way is, first of all you will be writing the set. Then for this coset you have to write all the set of pairs present in relation R. Thereafter draw a hash diagram. Then write the definition of lattice, what a lattice is, and then you are going to write LUB and GLB for every pair. If it exists, then finally your conclusion will be it is a lattice. I hope I am clear. Now let me show you a trick how to have this solution in much simpler way. Okay, a trick. Let me open my Excel that I will be able to show you a trick quickly. Till the Excel opens, have you heard about the concept of LCM and GCD? Have you heard of? There exists a concept of LCM and GCD. Yes, you have heard of. So we are now going to relate that LCD and GCM in the context of LUB and GLB. Okay. Now remember that whenever the problems are in the context of number theory, if numbers are given and you have been asked to compute whether it is lattice or not, it becomes difficult to interpret the diagram, hash diagram, and check out which one is least upper bound and which one is greatest. sorry, least upper bound and greatest lower bound. In that case, you can assume this LUB is equal to LCM and GLB, greatest lower bound, is equal to GCD of both the numbers. So what to do? You have to simply form a table of all numbers. So I am having one. I think this is, might not be visible. Let me make it bigger. Hold on. Now it will be visible. Look. So we will first construct a table for everything. Look. So let us have 1, 2, then 5, 7, then comes 10, then 14, and finally 35, and finally 70. I am taking all the elements in terms of rows as well as I will take the same in terms of columns. So I will simply write over here 1, 2, 5, 7, 10, 14, 35, 70. So first of all, we will construct a table for computing LUB for every pair. So no need of checking out the hash diagram. You can simply construct this table and you will have your answer. If all the entries of this table are filled, that means I do have join existing for every pair. 1, 1. What is the LCM of 1, 1? 1. What is the LCM of 1, 2? Least common multiple of 1, 2? 2. Least common multiple of 1, 5? 5. 1, 7, 7. 1, 10, 10. 1, 14, 14. 135, 35, 170, 70. Least common multiple I am talking about. Whether this is clear? Whether whatever I am discussing is making a sense or it is difficult? Making a sense. Okay. So can you tell me the contents of row number 2 now? What will be coming here? 2, 1. Should we have 2 or 1? 2, 1. Least common multiple. 2, 2, 2, 2, 2, 5, 5, 2, 7, 7, 2, 10. Whether we will have for 2, 5, 5 or something else. I want least common multiple. Okay. LCM of 2, 5, 10. Yeah. So that I was expecting. Whether you are blindly following me or you are actually checking out. 2, 7, 2, 7, 14. Okay. 2, 10. 2, 10 we will have 10 itself, isn't it? 2 side 5. 2 side 5. Yeah. 2, 14. 14 itself. 2, 35. 2, 35. 270, 70. Whether it is clear? Girls, I am not getting any replies from you. Yes, Pranali has given. Others, girls. So let us quickly fill out this table. 5. Okay, for 5, I am going to have 5. Then here 10. 5, then for 5, 7, what will be the result? I think 35, 5, 10, 10 itself, 5, 14, 5, 14, directly 70, yes, 5, 35, 35, 5, 70, 70. Any corrections in the row number 3? Row number 3, any corrections? I think no corrections are required. 7, then 7, 2, 14, 7, 5, 35, 7, 7, 7, 7, 10, directly 70, 7, 14, 7, 14, 14, 735, 35, 770, 70. Okay. 10, then 10 to 10, 1, 10, 10 2, 10, 10 5, 10, 10 7, 70, 10 10 10, 10 14, 70, 10 35, 70, 10 70, 70. Correct me if I'm going wrong. For those who are having internet connectivity issue or something and who have joined intermittently, we are trying to compute whether least upper bound exists for every pair in this hash diagram. I said whenever the hash diagram becomes complex, it will be easier to construct a table of LCM and GCD. So we are checking out LUB means LCM and GLB means GCD. Okay. So 14 1, 14 1, 14, 14 2, 14 2, 14 itself, 14 5, 70, directly 70. Okay. 14 7, 14 itself, 14 10, 70, 14 14, 14, 14 35, 70, 14 70, 70. We will cross check in the hash diagram as well. Okay, if my table entries are correct or wrong. 35 1, 35, 35 2, 70, 35 5, 35, 35 7, 7, 35 10, 70, 35 14, 70, 35 35, 35, 70, 35, 70. Okay. 71, 70, 72, 70, 75. Everything will be now 70. Okay. You have to simply replicate the things, nothing else. 70, 70, 70, 70, and 70. Whether anything is wrong in this table, whether all entries, 35 7, 35. Mahesh is saying, okay, let me check out. 35 7. Yes, yes, Mahesh. Yeah. Fine, 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 fine. I have forgotten. 35 7, 35. Least common multiple is it? Now, whether it is now clear? I have modified it. Okay. Now whether it is clear? Is it fine? Yes. Let's cross check for any random entry. So I will take 7 and this one is 10. Okay, let us check for 7 10. We are going to check this one. I will mark with red. Randomly I am talking. Okay, nothing. This one. Let us go with this one. Let us cross check for this one. So we will be checking out all these pairs. So check out whether we are having pair 1, 5 in the hash diagram. 1 5. What are the upper bounds of 1 5? Upper bounds of 1 are 2, 10, 70, 7, 35, 70, 14 and 5 as well. What are the upper bounds of 5? All these. Out of that, 5 is least upper bound of pair 1, 5. So I have got the same. For this 7 and 10, what are the least upper bounds? 7, 10. 7 and 10. So for both, I am observing that only 70 is acting as the least upper bound. In the similar manner for 14, 2. 2 and 14. Okay. We will be left with, I think I have written for 14 and 2, isn't it? 14 and 2. So for 14, I am observing that 70 is upper bound. For 2, 10, 70 is upper bound. Which one is least? 2 is having 14 as upper bound as well. So 14 will be the least upper bound. In the similar manner, you can check for 35 as well. So this is the table of LCM. In examination, you are supposed to draw this table and explain that there is no any single entry which is absent. Hence, least upper bound exists. In the similar manner, we will be constructing for GCD. So here, instead of join, you will be having meet, and you have to quickly tell me what entries should I have here. Okay. What is the greatest common divisor of 1 1? 1. Is it 1 1 1? 1 2 1. 1 5 1. 1 1 1 1 1. Okay. Are you ready for second row? Otherwise, it will be non-interactive. Okay, and I do not want non-interactive lecture. So you are going to tell me the contents of row number 2 for GCD. Row number 2 is clear. Okay. So tell me what will be there here in the row number 2. 2 1 2 1 1 2 2 element itself 2 5 2 5. What is the greatest common divisor of 2 5? 2 7 1. 2 10 2 10 greatest common divisor 2 10. 214 greatest common divisor of 214. 235. 270. I think I'm going wrong somewhere. Okay, so correct me if I'm going wrong. What will be there for 210? 210. What are the divisors of 2, 2 and 1? What are the divisors of 10? 10, 5, 2, 1. Out of these, which one is common? Is common. So I have taken. You can correct me if anything is wrong. 2, 5. Whether this row is correct or there is some modification anywhere. Which modification should I do? Where? Any modifications? No, correct. Okay, fine. So can you fill up the remaining entries in this table? We will move on towards the next example. Okay? It is your task. Just check out whether all entries are correct. I am keeping you up to you. Okay? Keeping this up to you. If anything is not clear, let me know. I am not skipping, but this can be done by yourself. Just fill out all the entries. Let us move ahead. So, example number 2 for lattice. Let A is set of factors of positive integer n and relation is divisibility on A. Same question, okay. It is slightly modified. X comma y, R is x comma y, such that x comma y belongs to A, comma x divides y. Check if set given by above relation for m equal to 45, m equal to 75, m equal to 20 forms a lattice. Are you getting this question? Or is there any problem? Let me know. While for checking out whether it is a lattice or not, first of all you will be writing relation. Okay, before writing relation, you have to find what is A, and on that A you will be defining a relation. Further to that, once the relation is defined, you will be drawing a hash diagram, and later on checking out LCM and GCD. That means LUP and GLB for every pair, and letting me know whether everything in the examples is forming a lattice or not. Whether the question is clear or any confusion in the question itself. No, girls, okay, girls are not responding. That means whether girls are not getting anything what is ongoing, or it is very simple and I am elaborating it okay in a depth. Whatever it may. So just take out this, and you'll be solving this in today's class only. One exercise that I am giving. Let x equal to 2 comma 3 comma 4 6 12 a a relationship with b if and only if a divides b. This is the relation given. Check if offset x comma divides is a lattice. All these examples have been asked many times in university examinations. Otherwise, tell me which one should I solve. I will solve one, and you will be trying all the remaining. But do not remain idle. Okay, respond in the chat box. I cannot understand what you are doing. Okay, if you are not responding. So have you taken the snapshot of this? I will explain the first example. Okay, for this m equal to 45, m equal to 45 will be quite bigger. So I will explain for m equal to 20. You can cross check for others. So, any responses? Have you taken the snapshot? Whether all there? Yes, all are there. Okay, okay, fine. This response is expected. No problem. So if you have taken the snapshot, event. So how to solve this first? What is given? A is a set of factors of positive integer m. So for example, number A. First of all, I need to find what is A. Can I discuss for A? No, I will discuss for C. Okay. So m equal to 20. Factors of 20: 1, 2, 4, 5, 10, 20. These are the factors of 20. Then we need to define R. R is what? R is all x comma y such that x divides y. So you are going to have pair 1, 1, 2, 2, up to. You should not write like up to, okay, in examination or anywhere while solving. You should write all the pairs compulsory. 1 divides 2, 1 divides 4, in similar manner 1 divides 20. Okay, what next? 2 divides 4, 2 divides 20, 10 is it? 2 divides 10, 2 divides 20. Only these three. So I am not writing now up to, okay, for this. I am directly writing next. 4 is dividing 20 directly. 5 divides 10. 5 also divides 20. Then 10 divides 20. So these will be the pairs present in your relation. Why? Because relation is x comma y such that x divides y. So this relation we are drawn. Okay. Now let us try to draw has a diagram for this relation R. Okay, let me make it new. So how many elements we are having in our example? 1, 2, 4, 5, 10, 20. And I should place it accordingly. So 1, 2. 2 should be placed above 1. 4 should be placed above 2. There is no comparison in between 4 and 5. 10 should be placed above 5. 20 should be placed above 10. Like this. So at the bottommost, I am going to have 1. Above 1, somewhere down the line, I should have 2. Above 2, I should have 4. So let me have here 4. Let me have the same hierarchy. If you take 5, then also it doesn't matter because 4 and 5 are non-comparable. Above 4 and 5, you can take somewhere 10, and above this 10, we will have somewhere 20. So now how to connect? 1 is connected with 2, 2 is connected with 4. This one is 10. Okay, this is not visible properly. 10. 4, 10, no relationship, but you are having a relationship between 5 and 10. Okay. And 5 is also connected with 20. What else I can have? 10 to 20. Yes, it is fine. And further to that, you will have some each connecting 4 to 20. So this is also a hash diagram. Okay, no problem. I do not have any directions. I do not have any self loops. I do not have any transitivity as well. 5 to 10, 10 to 20, 5 to 20. So 5 to 20 should not be drawn. Okay, because this is implied because of transitivity. So this arrow will not be present anywhere. Good. So 1 to 2, 2 to 4, 4 to 20 is needed because there is no intermediate. So this is the hash diagram for the given relation. Now we will be checking out for every pair whether there exists both LUB as well as GLB. So can you tell me whether it is a lattice or not? Whether it is a lattice? Whether this diagram is a lattice? Yes, it is a lattice. Yes, Shubham, correct. You can cross-check. For cross-checking and having a confirmed proof, I would suggest you to have a table of GCD and LC. So that's it from my side for lattices and cosets. These are the exercise questions that you should try without fail. You can respond personally with the solutions. This is a homework. Okay? So check out whether all are lattices or not. And do not miss tomorrow's class. Tomorrow I will be starting with the new topic, functions, part B from the same unit that we are dealing with, relations and functions. It is very important again. Okay. So